welcome back. We're going to be continuing our work with right triangles. This time, finishing up some trig, we're going to be looking at angles of elevation and depression. What we're working on today is we are going to be calculating those angles of elevation, depression, and we'll be using the geometric ratios and geometric functions of sine, cosine, and tangent in order to accomplish that. Before we get started, let's get some vocabulary words out of the way. We want to know what an angle of elevation and angle of depression are. Angle elevation is if you're standing flat like this and you look up at something, that angle that you tilt your head up, that's an angle of elevation. Conversely, if you're looking forward and you look down for something, that is your angle of depression. So angle of elevation goes up and angle of depression goes down. Taking a look at this graphic here that we are looking at our notes, we can see if someone is at the top of the stadium, their angle of depression, their line of sight going down to the person that's on the field, that would be an angle of depression. And this guy standing on the field has to look up at the person at the top of the stands. His is an angle of elevation. These horizontal lines that are the I'm just looking straight ahead are always going to be parallel. And so we can think about angle of elevation and angle of depression in this graphic as a pair of alternate interior angles. All right, let's look at example 1. This is an angle of elevation. Leah's on vacation and she wants to see a castle in an amusement park. She sees this castle and sights the top of the castle, this flag at the very top, with an angle of elevation of 38 degrees. She knows from the pamphlet that this castle is 190 feet tall. If Leah is 5.5 feet tall, how far away is she from the castle to the nearest foot? The first thing that we should do on this is to draw a quick sketch of the situation, and we have our quick sketch here. Now notice we know that the entire height of the castle is 190 feet, but she's 5.5 feet tall. That means that this piece right here, from where her eyes are to the top of the castle, is not 190 feet. This is actually 190 feet minus how tall she is. So this piece of the triangle right here that I'm coloring over in black is not 190, but rather 190 minus 5.5. My calculator gave me a measurement of 184.5 feet. That is the measurement of this side of our right triangle. We've been told the angle of elevation, that is this angle measurement here, and we are trying to find the length of this part of my triangle, how far away she is from that tallest point of the castle. This is a trigonometry problem. Here's my theta. This is my hypotenuse. And so now I need to think back to my trigonometric functions, and I'm going to use Sohcahtoa. Sine opposite hypotenuse, cosine adjacent hypotenuse, and tangent opposite adjacent. As I look at this figure, I notice that I have no information about the hypotenuse, and I don't want any information about the hypotenuse. So all of my trigonometry ratios that use hypotenuse, I'm going to throw away. Just not useful. That means that the tangent is the only one that's available to help me. So I'm going to write my trigonometric function equation as tangent of the angle that I was given, in this case 38 degrees, equals the side opposite that angle, that's the 184.5 feet that I had calculated at the very beginning, divided by the side adjacent to that angle, that is the distance that she is from the castle. That's x. Now I can solve for x. I'm going to multiply both sides by x, giving me x times the tangent of 38. Since I want x by itself, I'm going to divide both sides by the tangent of 38, giving me a final value that X, the distance that Leah is standing from the highest part of this tower, is 184.5 times the tangent of 38 degrees. I'm going to put all of that in my calculator, and I'm going to use my phone for my calculator because I don't remember where my class calculator ran off to. All right, in my calculator, hello, phone, hello, there we go. I'm typing in 184.5, then I'm going to push the tangent button, and then I'm going to type 38. I confirm that I am in degrees mode, and when I hit enter, I get a value of 144.15 feet. It wants it to the nearest foot, and so Leah is standing approximately 144 feet from the tallest point of this castle in the amusement park that she's visiting while on vacation. We can do the same thing for an angle of depression, and here in this word problem, we are faced with an emergency. A search and rescue team is airlifting people from the site of a boating accident when they observe another person in need of help. If the angle of depression to this other person is 42 degrees and the helicopter is 18 feet above the water, what's the horizontal distance that the rescuer has to swim to the person that they need help with to the nearest foot? Or if that rescuer is dangling from the rope, how far does the helicopter need to move sideways in order to put the rescuer right over the victim so that that rescuer can then slide down the rope, pull the victim up, and they can both get away to safety? Here's the sketch of that situation. Here's my helicopter with the rope dangling down and the rescuer here. That is 18 feet above the water. Here's the victim at point C in the water, and the angle of depression from where the helicopter is and his buddy sighting looking for more people to rescue, this angle is 42 degrees. I can copy that angle measure down to here because this horizontal and this horizontal that is the water surface are parallel, creating some alternate interior angles. All right, gonna look at Sohcahtoa again to decide which of my trig functions is gonna be of the most help to me. As I'm writing this down, we're looking at that diagram, that quick sketch that we made, and we notice that once again, we have no information about the hypotenuse and we don't care, which means the sine function and the cosine function we're throwing away, not necessary. So this is another tangent situation. All right, I'm going to write out that equation. That is the tangent of my angle of depression, which is 42 degrees, is equal to the measure of the side opposite the angle of 42, which is 18 feet, over the side adjacent to the angle 42, and that's what we're trying to calculate, x. Multiplying both sides by x gives me the phrase x tangent 42, which means x times the tangent of 42, equals 18. I'm going to divide both sides by tangent of 42 because I want to isolate the x, get the x all by itself. That will give me the numeric value of x. And I find that x is whatever I get when I take 18 and divide it by the tangent of 42 degrees. And I'm going to stick that in my calculator. You go ahead and pause this video right now while I push the buttons, and we'll come back together in a moment to see what our answer is. Welcome back. My calculator is showing that, whoa, sorry, my mouse got away from me. My calculator is showing that the horizontal distance to the victim, x, which is 18 divided by tangent of 42, is 19.991 feet. My word problem says to the nearest foot. So I'm going to round this to the nearest whole number and say that that helicopter needs to move a distance of about 20 feet in order to put the rescuer directly above the victim that the other person that they're in need of help they're going to rescue. Really, that's all there is to these. We just keep practicing. It's all about identifying, am I looking at an angle of elevation? Am I looking at an angle of depression? And using this concept of alternate interior angles to create some congruent angles so that you can move your angle measure into a useful place for you in a right triangle. Then use Sohcahtoa to help you remember which trigonometric ratio and function is the most helpful here. Write your function down as an equation, look at where your variable is, and solve for x. The only way I have of making this more challenging is to give us a couple of triangles together for us to deal with. In this particular problem, we have both Annabelle and Rich. They're setting up decorations for a school dance. Rich is standing 5 feet directly in front of Annabelle, and they are both near a disco ball that they've hung from the ceiling to put beautiful lights everywhere. If the angle of elevation from Annabelle's foot up to the disco ball is 40 degrees and Rich's angle of elevation is 50, how tall is the disco ball? All right, I've got the answer of 14.2 feet. Let's find out how the book calculated that. Okay, I don't know how far away Rich is from being directly underneath the disco ball, but we do know that he's 5 feet in front of Annabelle. So Annabelle is whatever distance Rich is, plus another 5 feet. Let's get some trigonometric ratios going. I'm gonna write my Sohcahtoa down so that I have it, and it's easier for me to think about which one might be the most helpful. As I'm writing this down, I'm looking at my figure and I notice in both of these situations, the situation looking at Annabelle, the situation looking from Rich's point of view, I don't have any information about the hypotenuse. So, whoops, I don't have an undo button. I don't have any information about the hypotenuse, and so I'm going to throw away both the sine function and the cosine function, leaving me with the tangent of the opposite over adjacent. All right, I'm going to write the tangent function from Annabelle's point of view. That is, the tangent of 40 degrees is equal to the opposite, which is x, divided by the adjacent, that is the 5 feet that she is further away from under the disco ball than Rich is, which is y. All right, there's one equation. And now I'm going to write the equation that models what's happening from Rich's point of view. From Rich's point of view, my trigonometric equation is the tangent of 50 degrees, 50 because that's the angle of elevation from Rich, is equal to the side opposite Rich, that is how high above the ground the disco ball is, divided by how far away he is standing from being directly underneath the disco ball. That's why. I have 2 equations, but I have 2 equations and 2 variables. So I can think of this as a system of equations. If I take this second equation, the equation that models the situation from Rich's point of view, I can very easily solve for x on this equation. I just multiply both sides by y. When I multiply both sides by y, the left-hand side is going to become y times the tangent of 50 equals x. X being how high the disco ball is off the floor. Now that I know a value for x, I can take this piece right here and substitute it into x. in this equation over here. Now this looks like it's going to be a hot mess, but bear with me. Let's go ahead and see how this works. I'm going to zoom in nice and tight just so that I can see what I'm writing, make it a little more clear. All right, I'm taking that first equation that says tangent of 40 equals x over stuff. Okay, instead of x, I'm going to write this expression here. That is y times the tangent of 50, because that's what I found x equaled in the second equation of this system. Put the division bar back and then 5 over y in the denominator. This is the expression now, or excuse me, this is the equation that I am wanting to solve for y. It looks like a hot mess because I have y's all over the place. I think the first thing I'm going to want to do is let me go ahead and get rid of this fraction. That fraction is a little concerning. So I'm going to multiply both sides by the denominator, not by the variable in the denominator, not by the number in the denominator, but by the entire denominator. So I'm going to, what I do to one side, I'm going to go ahead and do to the other side. I did not leave myself a lot of room. All right, there we go. And so now the left-hand side says, as a group, I have 5 plus y. That group is being multiplied to the tangent of 40. And that equals, now over here on this side, this denominator of divide by 5 plus y cancel with this multiply 5 plus y. And it leaves me with just the numerator, that y times tangent of 50 all by itself. All right, I still don't have y's all together, but I see that I can distribute here, or rather, let me erase. Erases weird things that I don't want erased. I don't know why. Okay, there we go. I'm going to distribute this tangent of 40 to both the 5 and to the y. And so that's going to give me 5 times the tangent of 40 plus y times the tangent of 40. Like we had discussed in class the other day, what we're doing looks like we're making it more complicated, but it's like cleaning your room. Sometimes you have to pull everything out of your sock drawer, make a big old mess all over the floor so that you can sort things out and make things look neat again. All right, looking at my situation here, I notice I have a y right here. So y appears on both sides of the equation. So I'm going to remove the term that has the y on the left-hand side. So I'm going to subtract y times the tangent of 40. And I'm going to go ahead and subtract that on the other side so that I have a minus y times the tangent of 40 on the right-hand side. Just going to put my little squiggly lines between my steps so I know what I'm doing. All right, the left-hand side now with those two canceling is just 5 times the tangent of 40. That's just a number by itself, so we're pretty happy with that. But on this other side, I have y tangent of 50 minus y tangent of 40. Now it feels like we should be able to subtract all of this and just have 50 minus 40. But unfortunately, we have all these other things happening to the 50 and the 40. I have the 50 and the 40 both getting shoved into the tangent box and stuff happening to them. And I have whatever result falls out of that tangent box getting multiplied to whatever y is. So I have to just hang on to it and write it as y tangent 50 minus y tangent 40. Now, because both of these have a y in common, I can factor out that y and rewrite this as y times the group tangent 50 minus tangent 40. So if I were to distribute this y out, I would get back to the line right above it. All right, gonna put my left-hand side back. There we go. And now to get y by itself, I need to divide by all of this stuff. All right, that's gonna go right over here. So the left-hand side is going to be 5 times the tangent of 40 divided by all of the stuff here that's in the parentheses, which is tangent 50 minus tangent 40. And all of that equals y. All right, we're going to go into my calculator. Go ahead and pause here if you would like. It's going to take me a little moment. I'm just going to blast through these really quick and write the numbers. I'll see you back here in just a few moments. If you've unpaused and you've finished out your answer, hopefully your work matches a little bit of what I'm doing right now. I'm just taking each of these trigonometric function things, everything that has a tangent, and I am just using my calculator to help me figure out the tangent of everything. So for the top, I did 5 times the tangent of 40. For the bottom, I did tangent 50, and then I wrote that down, and then I did tangent 40, and I'm in the process of writing that down. And all of that equals y. And then I'm going to keep calculating these. So I'm going to do the top number divided by the bottom grouping, and I'm putting that grouping in parentheses in my calculator, just so that my calculator knows that I want to do the subtraction before I divide. All right, and when I do that, I get a value for y of 11.89 stuff. While we're doing the calculations, I'm going to hold on to 4 decimal places worth of precision. So I'm going to round after 4. So that way I have the best chance of getting as close to the way it wants. According to my answer, it looks like we're rounding to about the 10th decimal place. All right. How high is the disco ball? I've already got a value. I've got a value of y. Let me zoom out and let me see which variable was the height of the disco ball. The variable for the height of the disco ball is x. The good news is that I've already solved for x right here. So I'm going to copy down that equation that says that x equals y times the tangent of 50. This is now something I can do because I've already calculated the value of y. I calculated the value of y in the previous step as 11.8971. So x equals 11.8971 times the tangent of 50. I've already calculated out the tangent of 50. I wrote it down right here, so no need for me to go to my calculator again just yet. I'm writing down the decimal expansion for tangent 50. Now I'm going to go to my calculator, multiply those things together, and let's see what I get. After calculation, it looks like the disco ball, according to my calculator, is 14.1783. That is more than enough because I rounded to 2 decimal places. 17 rounds to 2. I have my answer. So remember, when working with angles of elevation and angles of depression, you have to remember about the difference between those. Elevation is looking up, depression is looking down, and you can use trigonometry to help you calculate any of the missing distances that you're interested in. Thanks for joining me today. If you're new to the channel, thank you for joining me. I'm a teacher here at Science Academy in South Texas in the Rio Grande Valley of Texas, way down by the Mexican border. It's great to have you here. Please feel free to leave a like if you learned something new. If you remembered something old from your high school days, leave me a like. Comment, tell me how long it's been since you played with trigonometry. If you've got questions or you just want to ask me something about what I did you didn't quite understand, please leave it in the comment below. Happy to answer and help you out. If you're one of my students from the past, it's good to see you again. You are missed. Please let me know how you're doing in the comments below. Are you in college? Have you gotten a job? Are you married with a kid? Just let me know if you were one of mine. And if you're one of my current students this year, thank you so much for joining me. Thank you for subscribing. Please stay subscribed all year so that you can see when I post the next lecture. I try to have those out before you come to class so you can be prepared just by watching this video. Thank you again so much. We'll see you next time. Have a good one.